BSc Part 3 and respected listener, a very good morning, and welcome all of you to today's lecture. Dear students of BSc Part 3, I will deliver today the lecture on that is of selection rule for linear and that is of band spectrum. The title which is selected from BSc Part 3 Paper 3 Physical Chemistry, selected from that is of Unit 3 titled as that is of spectroscopy. Dear students, now may I have attention please that once again I repeat about our previous lecture we were expressing in our kinds of the spectrum, in which spectrum actually has been divided into two types. Further its classification as emission spectrum and that is of absorption spectrum. Emission spectrum and absorption spectrum further divided into that is of continuous spectrum and that is of discontinuous that is of spectrum here. Emission spectrum is the spectrum in which when extra energy is provided to the system or any substance possessing higher energy, when extra energy is allowed to emit into that is of a radiator and further allowed to transmit into that is a photographic plate, the spectrum produced is known as that is of emission spectrum. In the case of absorption spectrum, yesterday I have delivered in the classroom. Absorption spectrum is the spectrum in which when the substance having or possess the low energy, when is provided the extra energy. I mean to say a few radiation will now be allowed into that is of radiator and further allowed to transmit into that is a photographic plate. The spectrum is now produced obtained is known as that is of absorption spectrum. Dear students, further emission and absorption spectrum further divided into that is of continuous spectrum and that is of discontinuous spectrum. Also further discontinuous spectrum further divided into that is of linear spectrum, that is of band spectrum. Linear spectrum is also known as that is of atomic spectrum because linear spectrum is produced by that is of atomic species. Here atomic species must be present in the form of that is of gases or that is of vapor phase. In the case of that is of band spectrum, which is produced and obtained from that is of molecular species must be present into that is of liquid or that is of solution phase also. Dear students, now next topic I will proceed of spectroscopy. Today's lecture that is of selection rule for that is of linear spectrum and that is of band spectra or that is of molecular spectrum. Dear students, yesterday we also described, we have also defined in the classroom that there are two types of the important conditions for that is of selection rules. Selection rules we have also defined yesterday's lecture. Selection rule, that is the measure parameter to define the exact classification of spectrum by means of intensity, wavelength, wave number and that is of various kinds of region of electromagnetic waves here. The first one condition that is allowed for the formation of that is of spectrum here, that is of same orbital. Such condition is known as that is of forbidden transition. The graphical representation graphs, it has been shown, it has been drawn on the blackboard here. Two types of the condition applicable for that is of selection rule and for the transition of electrons in various energy levels to obtain perfection of the spectrum. First that is of same orbitals, forbidden transitions. You know here SS, the transition of the electrons will not be allowed. In the case of S to S, P to P, same to same means S orbital to S orbital, P orbital to next P orbital, similarly D orbital to next D orbitals, F orbital to that is of F next orbitals by that is of shape and size and graphs. It has also been proved by that is of 1s is not allowed to that is of transition of the electron into next 2s. Similarly 2p will not be allowed to transit that is of next 2p orbitals here. Same orbitals, such condition that is known as that is of forbidden that is of transition on the behalf of energy levels of various orbitals. 1s as per that is of will not be allowed to transit that is of 1s to 2s. Similarly you know here 2s to that is of 3s, it has been shown by that is of cross here. 1s same orbitals not allowed, not will be allowed, not transisted here. Similarly, that is of 2s and that is of 3s will not be allowed here, and for that is of per rule of selection rule here. Similarly, in the case of that is of what does the selection rule say? For that is of oppositely, that is of orbitals here. In this opposite orbitals, such conditions, such transition will be allowed here, and it has been shown by graphical representation here. You know on the blackboard here, that is of opposite orbitals. This one S orbitals, this one that is of opposite means that is of p orbitals. P and the D, the tick or that is the right mark here has been shown here. Transition, exact perfection of the transitions of the electrons will be allowed here. S to P, next P to D. Similarly, on the behalf of energy levels, it has been perfectly clearly shows obvious that there is no doubt for the transmission or for the transition of the electrons in that is of oppositely shape and size of the orbitals here. 1s will be allowed to that is of 1s different, that is of its nature 2p. So I on the behalf of tick mark here, 1s transition of the electrons will be allowed into that is of next 2p. Similarly, 2s to that is of 3p on the behalf of tick marks. Then on the behalf of different shape and size of the orbitals, such condition is known as that is of allowed transition according to that is of per rules and regulations of selection rule here. Now, dear students, in the next topic I will deliver here. Let us proceed. Today's lecture, that is of quantum mechanical condition for absorption and that is of emission spectra. Dear students, we are going to deliver our lecture on emission spectra and its classification on the behalf of various factors, wavelength, wave number, intensity. Dear student, now let us go deeper and deepest about that is of what are the quantum mechanical conditions of that is of absorption and that is of emission spectrum. Here, that is of two types of the energy level has been drawn on the blackboard here, even in that is of E2, even that is of lower energy levels, E2 that is of higher energy levels. Let us give extra heat energy of this electron. Obviously, there is not any kinds of doubt. Electrons after absorbing of the energy of the photon here. Once again, listen to me. When extra energy in the form of photons, extra intensity, radiation, or in other words, when a beam of monochromatic light is incident upon the electron which is present in lower energy levels, after the absorption, electron will jump from lower energy level to that is of higher energy levels. In such a position, the spectrum is obtained, is known as that is of absorption spectrum. But according to that is of Schrodinger wave mechanics, according to that is of quantum mechanical conditions here, the electron which is jumping, moving from that is of lower energy level even to higher energy level is now that is of unstable, and after emission of the extra energy of the photon, now it will that is of emit and will come back into its original or ground state. In such a position, the spectrum is produced, obtained, is known as that is of emission spectrum. And you know, according to Schrodinger wave equation, Pauli's rule, Alpesel rule, Hund's fundamentally that is of Planck's rule, that three types of the transitions occur in various energy levels according to very special conditions, very special outstanding condition, quantum mechanical condition for the transition of the electrons in various energy levels. Three types of the dear students, that is of three types of the transitions occur in energy levels. First one, that is of electronic vibration, that is of rotational. It has been the such types of the important conditions strict by that is of Schrodinger wave equation, quantum mechanical condition, where when we provide extra energy in the form of that is a photon for any electrons, after absorbing the electron will jump from lower energy level to the higher energy levels. And since the electron is after absorbing from lower energy level to that is of higher energy levels, that is of here unstable, and will try to come back after emission of the energy, and it will come back into its that is of lower energy levels or ground state. In such a position, the spectrum obtained is known as that is of emission spectrum. Such types, when electrons is jumping, three types of the that is of emission occurs observed, that is electronic vibration and that is of rotational here. And the order here, look at the blackboard here, the order of I have mentioned here right hand side on the blackboard here. the energy of electron is higher to that is the vibration, the transition, rotation will be higher to that is the E dot. The order for in compact form, for remember I have mentioned the blackboard here, E, V, R. E means electronic, V for vibration, and R for that is of rotational here. Dear students, here once again you know here electronic transitions, these are formed in UV plus visible regions, and that is of vibration spectra recorded obtained in that is of IR, and rotational spectra has been produced in that is of FIR plus that is of MW, that is of microwave. And rest further classification selection rule of these various electronic vibration rotational spectra in various region we will deliver it, that is of tomorrow. Thank you very much.